Good afternoon. I'm Spot On Weather meteorologist Matthew Euler, and welcome to a very exciting training video today. I'm going to break off of the How the Weather Works training series with occasional topics. This is one of those topics, and it's simply doing weather forecasting using the clouds, looking at the sky, and being aware of the type of clouds, how they change over time and coverage. You can be an expert forecaster yourself if you just simply take a look at these clouds with me in today's training, really delve into the different types. It's going to be an exciting training session today. Now, all the clouds in this training are basically courtesy of all the photos I've taken of the clouds here in southeastern Virginia. This is a prime example, the cover sheet here, the cover slide of today's presentation, showing these mid-level clouds. And this is a sunrise picture looking east-southeast, generally showing the sun's rays reflecting off the bottom of these mid-level clouds. And this happened in Halloween a couple years ago. It really looked like a very eerie sky. I like to call it like a witch's sky, and it was very time appropriate, being that it was Halloween, for this particular picture I took of the clouds on this particular morning around sunrise. So again, I'm going to teach you today in today's training how to forecast using clouds. All right, so first of all, my interest in observing cloud types and the weather associated with each of the types, this has spanned the past 4 decades. I joke around about this with people I know and literally say, my head is literally in the clouds. I'm constantly paying attention to the various clouds. I do a lot of posting on social media of the various cloud types, the sky, and I've really keyed in on the art of observation and looking at these clouds, because these clouds are weather's visual clues. They tell us what's going on in the atmosphere. Now, weather forecasting, in my opinion, is really 90 to 95% observation. It's paying attention to those surroundings. In this particular training, I'm emphasizing the sky, the types of clouds. If you can master the art of observation over an extended period of time, and so this takes a little time, but you can definitely do it no matter where you're watching the video from. You can accurately forecast the weather without even looking at the weather model forecasts or the nightly TV meteorologist. If you just can pay attention and get down the art of observation, it will work a lot of wonders. In fact, I remember when I was a young boy, one of the first weather books I ever got and started reading was the Weather Wizard's Cloud Book. And I would just be like, reading through the book. A very similar theme is what I'm basically saying in today's training, that you can really learn a lot by paying attention to the clouds. Now, with this in mind, I decided to develop this guide with a focus on Virginia weather, where we're at here at Spot On Weather, and we're in southeastern Virginia. Now, some of these rules will still apply at other locations too. So, this is, from what I've observed, I've been in Virginia now for about 10 years, and I've just watched clouds. And no matter where I've been across the whole entire world, I have watched clouds. I've watched clouds from ships. I've watched clouds from land. I've watched how the atmosphere unfolds, and the clues are there in the clouds. So the main focus of this training guide is to include my own actual cloud photos and basically tell you what type of weather these clouds indicate. Now, you can go out there and buy cloud charts. If you Google it online, you'll find them. And they typically take into account the cloud types, the barometric pressure tendencies, as well as the surface winds. What direction is that wind blowing from? In order for us to really talk about clouds and weather, we need to first talk about cloud formation. How do these billowing, visible images in the sky, how do they come to fruition? In order to get clouds to form, we must need some sort of lifting mechanism in place such as heating at the Earth's surface, or a frontal boundary coming in to lift the air mass, or orographical or mountain lift. These are just a few of the ways in which the air rises. Now, when the air rises, it's going to cool, it's going to expand until the air parcel is going to reach saturation. And when the saturation actually occurs is when the cloud is formed. And this is as if you were to look up at the sky. When you look up at the sky, this is where you see the cloud base, the bottom layer of the cloud. That's where the saturation is reached. Now, the cloud base is going to vary depending, what I mean by cloud base varying, I mean the height. The height of the cloud base is going to vary depending on your specific location, where you live. For example, the cloud bases over the desert southwest are going to be much higher. So let's say you have a cumulus cloud in the desert southwest. Your cloud base may be 4,000 to 5,000 feet above the ground. Whereas if you live, let's say, on the Gulf Coast, places like Houston, a place like Houston, Texas, New Orleans, Mississippi, the Florida Panhandle in the summer, your cloud base is going to be much closer to the Earth's surface because it's so much more humid and there's so much more moisture in the atmosphere. Now, when we talk about clouds, we talk about how they form. And let me go back here. I wanted to mention one more thing I failed to mention here. Additionally, in order to get clouds to form, we have the lifting, yes, but we also need some form of impurities in the atmosphere for this water vapor to condense around. For the water droplets to grow, you have to have an impurity, or basically a nucleus, for these cloud droplets to really develop. So basically, if we lived in a pure atmosphere with no impurities, no dust, no smoke, stuff like that, no haze, we wouldn't really be able to get clouds to form. So I did want to mention that as well. All right, so now let's turn our attention to cloud types and stability. Now, generally, you have a couple conditions of the atmosphere I'm going to talk about. I'm going to talk about an unstable atmosphere as well as a stable atmosphere. So when the atmosphere is unstable, clouds are going to take on a more puffy appearance. These are usually associated with these cumulus clouds. Now, this instability of the atmosphere, it could be caused by a couple different factors. It could be caused by colder air higher above the ground moving in aloft over a heated land, for example. And that happens a lot. You have cooler air aloft in that very warm, heated land in the summertime. The instability can also be caused by a cold front with cold, dense air basically staying close to the Earth's surface, lifting warm, moist air, unstable air ahead of it. Additionally, you get intense surface heating during the summertime as well. So there's a couple different mechanisms that causes instability of the atmosphere. Now, when the atmosphere is stable, on the other hand, clouds are going to take on a more layered appearance, forming these stratus clouds or stratiform clouds. Here's a couple examples of stratus clouds. We have just regular stratus. We have mid-level altostratus. We have higher level cirrostratus. And then we have actually a more of a continuous precipitation producing cloud known as nimbostratus. Right, so the slope. I want to talk a little bit about slope. Slope is basically rise in the vertical over run, which equates to the horizontal. That slope of a front, for example, is going to play a large role on the cloud types observed in the sky. When you have a steeper frontal slope, let's say the air rises 1 mile in the vertical to every 50 miles in the horizontal, that is considered a steep slope. And we can expect to see billowing taller clouds in the sky and the potential for showers and thunderstorms in a particular area. All right, so slope, generally the steeper the slope, the more vigorous the warm, moist air ahead of the front. Most of the time we're talking about slopes, we talk about cold fronts and warm fronts. But in general, the steeper the slope, the more unstable the atmosphere, the more vigorously lifted the air is going to be ahead of frontal boundaries. Additionally, we can get clouds to grow tall during the summer season with air mass instability taking place. And this is, again, due to a strongly heated surface in the summer and cooler air aloft. Anytime you get cooler air over a heated surface, it's an unstable atmosphere situation. Now, with a more gradual or shallow slope, an example of that would be 1 mile in the vertical for every 300 miles in the horizontal. We can expect to see layered clouds over a great horizontal distance, and this kind of gradual or shallow slope typically occurs with warm fronts during the winter season especially. We get more of a gradual ascent of rising air in the winter season as compared to the summer season, where the Earth's surface is heated much more intensely. In order to reestablish temperature equilibrium in the vertical, you get much more vigorous rising air motion in the summer season, and that redistribution of heat from the low levels towards the upper levels of the atmosphere. Right, some other important notes about stability. Showery precipitation it's considered showery, any kind of precipitation that falls when it starts and stops quickly. So showers typically fall from cumulus clouds because you have greater up and down motion within these type of clouds, cumulus. And one other thing I pay close attention to when I see rain hitting the pavement, for example, is I pay attention to the rain droplet diameter. Raindrops are going to be much larger, much bigger in diameter, indicating greater instability and a lot of the up and down motion within the clouds during showery precipitation, specifically during the summer when you get showers and thunderstorms to develop. And you may note this too, maybe just driving down the road and you notice how the raindrops hit your car windshield, and you'll notice the size of the drops, how big or small they are. Now, more steady precipitation usually falls from stratiform or layered clouds, most predominantly nimbostratus clouds, and tends to last longer. Raindrops are much smaller in diameter, indicating a more stable atmosphere. So smaller the raindrop diameter, the more stable the atmosphere is. Cloud types can definitely change throughout the course of a day as well. So we can go, like during the summertime, from more of a stable atmosphere where we see these low-level gray stratus clouds, and then as the sun comes up and heats the Earth's surface, by the middle of the afternoon, we're starting to see these billowing cumulus clouds, these towering cumulus later in the afternoon, as the heating from the sun destabilizes the atmosphere. This is especially common when you have a warm and moist maritime tropical air mass across the eastern U.S. during the summer season, where things are very unstable. Overall, when we talk about clouds and weather, appearance really does matter. If you see a puffy cloud versus a layered cloud, that tells you a lot of what is going on in the atmosphere on a particular day. Just by looking at the sky, you can gain a lot of important information. Now, knowing your main synoptic weather features, what do I mean by these? Synoptic weather features. Throughout the course of a year at a particular location, the weather works in a very cyclical manner, very progressive manner, where you may have areas of low pressure or areas of high pressure that tend to transit in and out of your area, becoming familiar with those, as well as the different types of fronts that work their way through your area. If you live in a mountainous area, you also have to take into account some of the local scale effects with mountain and valley breezes. So it's important just to really know, pay attention to the weather charts and kind of get that relationship down in your mind. Looking up at the sky, looking at the type of clouds for that day, looking at a surface weather chart to really connect the dots between the sky and what's going on at the surface where we live. Additionally, it's always important to know the different types of air masses that work into your area throughout the course of the year. Now, in Virginia, if you live in Virginia, we are predominantly influenced by hot and humid maritime tropical air masses in the summer season. On the backside of the Bermuda or the Azores high pressure system, the subtropical high that sits in the Atlantic and it really strengthens during the summer season, the Bermuda Azores high, and the fronts are trying to basically work their way, cool fronts try to work their way in from the northwest, but because of the strength of the Bermuda High, they just cannot push their way through like they do during the fall, winter, and spring times of year. So we got a lot of southwesterly flow, a clockwise flow around the Bermuda Azores high pressure system. Southwest winds are the predominant wind direction type during the summer season along the East Coast in general. Now in Virginia, we are also influenced by, in addition to the maritime tropical air masses, summer with the hot and humid air, we also see maritime polar air masses, continental polar air masses in the wintertime. Additionally, we see a lot of frequently passing low pressure systems along with frontal boundaries. I put cold fronts on here, but also we do see warm frontal passages quite a bit during the course of the year across Virginia. Occasionally, we will see Arctic air masses that will intrude. Continental Arctic air masses move in as well. Those are the extremely cold air masses and very dry. A quick review on air masses. Since we're talking about air masses, they're very important in determining the stability of the atmosphere. Now, I have a graphic on the left that kind of breaks down the different air masses across the United States. You'll notice there's different source regions associated with these air masses. For example, maritime tropical air masses, it's abbreviated MT, in the green shading there. It generally shows where they develop and where they predominantly are located throughout the course of a year, usually over the tropical Atlantic into the Caribbean, into the Gulf of Mexico. You see maritime tropical air. Off the Pacific coast of the United States, they typically reside down south of 30 degrees north latitude out through Hawaii. Additionally, you'll have maritime polar air masses, which they're abbreviated MP. And they are generally formed over the North Atlantic and North Pacific Ocean, over the unfrozen waters. And then additionally, there's CP, continental polar air masses, which their source region tends to come from Canada, and they tend to be much colder during the winter season as compared to summer season. And then the very top of the graphic on the left, you'll see the CA abbreviation. That's for continental Arctic, and that's the extremely cold air, very cold air up over the polar areas. Now I'm going to focus in a little bit on Virginia. I want to give everybody out there the overview, no matter where you're watching this from in the United States. You can kind of get a feel for the trajectory as well as the different types of air masses and where they typically are positioned. I want to focus on Virginia now. We'll talk about maritime tropical, maritime polar, and continental polar. Those right there are the three main air masses that impact Virginia over the course of the year. Now, maritime tropical air is characterized by that warm, sticky, muggy conditions, very warm and muggy during the summer season when you're just sweating. The dew points get into the lower to middle, sometimes even the upper 70s with this type of air mass. Source region is the Gulf of Mexico as well as the southwestern North Atlantic. And with a maritime tropical air mass, these generally lead to an unstable atmosphere when they move into the area. We can expect to see more in the way of showers and cumulus, puffy clouds, especially during the summer season with maritime tropical air mass when it's just heated. It wants to rise on its own, and throughout the course of the afternoon, it's typical to get these air mass thunderstorms associated with maritime tropical air. Now, maritime polar air masses are characterized by cool and moist conditions. They're damp and chilly. They give you that dull gray overcast of low stratus type clouds off the ocean during the late winter, early spring, and November. A source region is generally the North Atlantic for maritime polar air masses, and the wind is going to blow over very cool, unfrozen waters of the North Atlantic, or if you live on the Pacific Northwest, over the unfrozen waters of the North Pacific. Either way, maritime polar, maritime being moist over an ocean surface, and of course polar being cooler. But in general, the wind's going to blow over very cool waters onto land, and maritime polar air masses are associated with sometimes they're associated with what's known as backdoor cold fronts and these stratocumulus, these layered cumulus clouds that come in off the ocean. Now, continental polar air masses, abbreviated CP on the graphic on the left, they're characterized by cold, dry air. Usually in the wintertime, you get strong, gusty northwest winds, which bring these air masses down into the mid-Atlantic from Canada. And they do during the summertime. If you get a cool front to blow through, you sometimes get this continental polar air mass. When continental polar air mass gets modified, if it has a trajectory over the North Atlantic, it transitions to maritime polar air masses. But generally, in the summertime, CP or continental polar air is going to give you just a slight reprieve from the oppressive humidity. Generally, continental polar air produces mainly clear skies, rising barometric pressure, especially in the wintertime. The pressure gets quite high. Occasionally, with a north wind in winter, if you have a continental polar air mass moving in from Canada, you will see these flattened stratocumulus clouds develop downwind of the Chesapeake Bay into Hampton Roads cities, for example. And that is a bay streamer effect. And basically what you have is cold, dry continental polar air moving over relatively warmer waters of the Chesapeake Bay. If the wind is from the north, it's going to basically direct those clouds straight south from the Chesapeake Bay into southeastern Virginia. Source region, again, for continental polar air masses is Canada. Now, it's also important to note, in addition to air masses, in addition to what you're looking for in the sky as far as cloud types, stable versus unstable, it's also important to note the wind directions. Now, the wind directions are a little bit different depending on where you live. What they mean, in particular for your weather, it is dependent, okay? For example, I'm originally from the Midwestern U.S., and whenever we got a northeasterly wind in wintertime, that usually indicated a very cool, moist air mass, which northeasterly winds in the Midwest generally resulted in major snowstorms. That's not the case in southeastern Virginia or coastal areas of the East Coast, especially Virginia and the Carolinas. When you get a northeasterly wind in winter, it's a very chilly, damp wind, but a lot of times it results in cold rain. So that's just an example of different geography where you live and what the winds mean in particular. For Virginia, I will say that a northwesterly wind is usually going to result in drying of the air column and usually a clear sky. This usually occurs as high pressure is building in from the northwest. So a northwesterly wind indicates fair weather. A northerly wind generally results in a dry air mass. As I mentioned on the previous slide, occasionally you'll see these bay streamers set up or a stratocumulus cloud field appears in the sky as cold, dry continental polar air moves over the fetch, the distance of the Chesapeake Bay over those relatively warmer waters. When that cold, dry air moves over the relatively warmer waters, it picks up warmth and moisture from below, and the air rises, and you get these clouds downwind of the Chesapeake Bay. Strong northerly winds can also result in times when we get snow showers for Hampton Roads cities during the winter season, especially the early part of the season, when the Chesapeake Bay water temps are still relatively mild, and you get that colder air aloft moving over the surface. A northeasterly wind in Virginia generally results in increasing cloud coverage and they're usually the stratocumulus type. I'll show you some pictures of what those look like here in a moment. A mostly cloudy to cloudy sky is going to take place with a dull gray appearance. May produce drizzle if the clouds are thick enough, especially during the winter season. You might get a little bit of drizzle out of these, but nothing significant. An east to southeast wind across coastal Virginia, that wind results in increasing low-level moisture, rising dew points, and a partly cloudy sky usually. Now, if we have a coastal storm that's moving up the coast, we will see a cloudy sky instead, and that may result in the onset of precipitation, especially during the winter season. A south-southwest wind across southeast Virginia is usually associated with muggy conditions during the summer season. And when we get a south-southwest wind in the winter season, it can result in dramatic rises in air temperature. I'm talking on the order of 20 to 30 degrees Fahrenheit when you get a really strong southwest wind. I've seen this happen before in the wintertime. The morning may be about 32 degrees, and the afternoon may be up to like 58 degrees Fahrenheit. So things can change rather quickly with these stronger southwest winds in the winter season. But in the summertime, southwest winds are the main wind direction. It's the main wind direction you're going to see. Southwest winds, as I mentioned, there you go. Predominant winds during the summer. which brings day after day of just heat and humidity into southeastern Virginia. You're blowing the air from that maritime tropical source region, the Gulf of Mexico, straight up into the mid-Atlantic, and that's going to result in a lot of heat and humidity day after day. There's very little break in that, especially as we get into the months of July and August, even into parts of early September. You see a lot of maritime tropical air mass in place with predominant southwesterly winds. Now, during the winter time, the southwest winds, again, as I mentioned on the previous slide, they're going to bring in much milder air into the area over a relatively short time period, especially if those winds are strong. And there's another example of, I've seen winter days like this where the wind changes direction to the southwest. It increases, becomes gusty, maybe it's 15 to 25 miles per hour. And that warm air vection, that warm, moist air moves in. And here's another example. You might have a temperature, a morning low near 30 degrees Fahrenheit, and that can be quickly replaced by a temperature of 55 degrees Fahrenheit during the afternoon. A westerly wind across southeast Virginia, that's usually associated with dry weather and a lack of clouds. And we have to look at the geography here because to the west of southeastern Virginia, as an example, we have the Appalachian Mountains. And what happens is as westerly winds hit the Appalachian Mountains, the air rises on that windward side, all the moisture precipitates out of the clouds, and then air sinks. As air sinks on the leeward side, it warms and dries out. And so what you get occasionally in the upper levels of the atmosphere, you still have enough moisture downstream of the mountain peak, and you get what are known as these standing gravity wave clouds, these Kelvin-Helmholtz clouds, which form downwind of the Appalachian Mountains. But usually with a west wind, even with these standing gravity wave clouds or these Kelvin-Helmholtz clouds, you're not going to get any precipitation to really occur. All right, and as I mentioned earlier, the seasons matter. This is so apparent. I've watched the sky change from stratus in the winter, predominant stratus clouds in the winter, to predominant cumulus clouds in the summer season. And it's very cyclical. It's like clockwork. It's like watching things repeat over and over and over. Now, with seasons, we have to think about this. The graphic on the left, we have more of a stratus cloud, layered clouds on the left. That's during the winter season when our weather is dominated by broad-scale lift over greater horizontal distances associated with mid-latitude cyclones. This results in more layered stratus or stratiform clouds and more continuous precipitation over longer time periods. The graphic on the left shows that as warm air moves up and over colder air at the surface in association with this warm front. And remember earlier I said that the warm front has a much more gradual slope. It may be on the order of 1 mile in the vertical to 300 miles in the horizontal. The graphic on the right shows what it will look like during the summertime, where we get these puffy cumulus clouds to develop. We see more intense heating of the Earth's surface throughout the course of the day. And as the air is heated at the surface, the air parcels rise, they cool, they expand, eventually they reach saturation, and that change from water vapor to a liquid occurs. That's known as condensation. This results in air mass thunderstorms on a pretty regular basis during the peak heating time of the day, usually in the afternoon into the evening hours. Heavy showers, gusty winds, dangerous lightning occur from what's known as cumulonimbus clouds, which are the true thunderstorm clouds. But you see on the right the graphic how the air is more vertical in its motion. Air is rising in the vertical more than it is in the horizontal with the graphic on the right during the summer season, as the excessive heat at the Earth's surface is being lifted skyward to help reestablish thermal or temperature equilibrium. Those are by the way, that graphic on the right shows the various stages of an air mass thunderstorm, starting with the towering cumulus stage on the far left. The middle part of that graphic shows a mature stage where we're at max intensity of a thunderstorm. We have rain falling down out of the cloud. We have the gustiest winds occur with the mature stage of the thunderstorm. The cloud reaches its tallest height, and then eventually cooler rain-cooled air actually just descends out of the base of the thunderstorm, and it actually dissipates the thunderstorm in general. All right, so Looking specifically at, again, you can apply this if you're watching us from, let's say, the Midwest or the Southeast New England. These clouds usually have similar meanings no matter where you live, but I am focusing on southeastern Virginia in particular here. I'm going to start with the winter season clouds across southeastern Virginia. The sky is predominantly dominated by stratiform or stratus clouds, and usually you see a lot of layers, and they can occur at different altitudes. For example, cirrostratus occur at the higher levels of the atmosphere. Altostratus occur at the mid levels of the atmosphere. Nimbostratus occur, they start at the mid levels of the atmosphere, and when they start precipitating out, precip starts falling from them. The atmosphere is so saturated that the nimbostratus can actually lower to the lower cloud area. Nimbostratus, by the way, are those continuous precipitation days where it's just kind of nasty all day long. Low stratus occur during the winter season as well, and when we have them on the ground, we call a stratus cloud on the ground fog. Now, these stratus clouds usually are dull gray in appearance. They completely cover the sky. Some days never get very bright due to how thick these clouds can get, and also during like the winter season, the months of December, January, we have very low solar radiation that's actually trying to work its way through the clouds. And so this might be one of these days where it just appears like it's dark all day long. You might go to work in the morning and it feels like it's dark, your headlights are on in your car, and then when you come home in the afternoon, it's still the same way. Now in the following slides, I'm going to break down the specific cloud types and what they mean during the winter. We're going to start off with this stratus cloud. Now, stratus clouds occur in winter due to a highly saturated air mass, so our temperature and dew point are close together. They're most common when you get warm, moist air moving over a colder surface. So, for example, if I have a maritime tropical air mass in the winter moving over a colder ground, I generally tend to get some stratus. In some cases, I get fog, which is shown there in the picture on the left. This is taken in the Pembroke area of Virginia Beach, by the way. But look how you can't even see the top of that building. This was a late December day. Now, these stratus can be more persistent overnight into the early morning hours. And that's mainly due to the fact that, we have longer hours of darkness, and we just don't have, the solar radiation is weaker during the winter season. Drizzle is going to be the most common weather you associate with stratus. They're not very tall in the vertical. They're generally, again, spread out horizontally. So there's not a lot of up and down motion in the stratus clouds. You might even see like these droplets that are kind of just appear to be floating in the air, this drizzle, very small diameter droplets. And that actually happened in late December when I took this picture down in the Pembroke area of Virginia Beach. It was one of those type of days where we just had a little bit of drizzle at times, and that was it. It was just a very cool day overall. Now, stratus can also occur other times of the year outside of winter season. So I do say that stratus or layered clouds are the predominant clouds during the winter season for Southeast Virginia, but there are other times where you can see stratus clouds throughout the course of the year. Stratus can occur outside of the winter season, as I mentioned. Note in both pictures here on the left, this is taken in Virginia Beach area. Notice the dull gray stratus cloud deck, how they look. They can occur in early spring and late fall as well as winter. They occur when you typically get maritime polar air moving in off the North Atlantic. That typically occurs with more of a northeasterly wind, onshore northeasterly wind during any time from the early spring, late fall, and especially the winter time. Cool temps with light rain is possible, especially if they're a little thicker in nature, right? So we talked about fog and stratus here, more of a drizzle producer. If you get a thick enough deck of clouds, stratus clouds, or let's say stratocumulus clouds, you might be able to get a little bit of light rain out of those clouds, but it's not going to be very heavy, it's not going to be long lasting, and most likely it's not going to be very frequent. But again, take a look at the pictures I took. Generally a dull gray appearance. Additional winter season stratus here in these pictures, these 4 images. Again, a dull gray appearance is common. Look at the picture on the left there, just showing a dull gray appearance. That is very common during the winter season across southeastern Virginia. Additionally, as that air rises, it rises over a much broader scale in association with middle latitude cyclones. So air is rising more in the horizontal than it is in the vertical. Generally, you see these type of low, dull gray stratus clouds closest to the winter solstice around December 21st with this type of low, thick cloud cover in place. Again, the days do not get very bright at all. In general, progression occurs when you have mid-latitude cyclones approaching. You generally start off with progression of cirrostratus clouds, which are associated with a phenomenon known as a halo, which I'll show you here in a bit. Altostratus clouds and the nimbostratus clouds are the precipitation-producing clouds. As you get closer to the center of a low-pressure system, that's typically the sequence you see. Higher cirrostratus, lowering to mid-level altostratus, lowering to thicker nimbostratus. Now, some of the most severe winter storms are associated with precipitation-producing nimbostratus. If you look at my second image there, I took one snowy winter day. Look at how the ground is snow covered, and that was one of our bigger storms across Hampton Road cities in southeast Virginia. This particular storm occurred in January, and it yielded, I believe this one was an 8-inch snowstorm, total accumulation. You can see I'm standing on the street in that second picture. In general, you see the dull gray overhead stratus clouds. Additionally, there's a couple other images here. The 2 on the right, again, associated with wintertime stratus and mid-latitude cyclones. Look how thick and dull and low these clouds appear. Now, I've noticed this over time, across southeastern Virginia in particular, where the sky transitions from this dull stratus look to more of a puffy cumulus look. The sky appears to get brighter each April. The sky transitions from more of a layered stratus cloud like these to more of a puffy cumulus cloud across southeastern Virginia. Now, this transition is due to the fact that the sun is higher in the sky. And in addition, we have this increasing solar radiation which is occurring during April, and especially as we work our way into May, definitely June, and throughout the rest of the summer. As radiation increases from the sun, the Earth's surface, again, is going to be heated much more efficiently, resulting in the establishment of these convective currents. What do I mean by convective currents? Air that's rising in the vertical, rising and sinking in the vertical. There's a lot of upward and downward vertical motion because of how much of a temperature difference occurs in the vertical between the heated surface in the summer and higher up, let's say above 5,000 up to 10,000 feet. At times, you may get showery precipitation from cumuliform clouds, especially if the air mass is unstable. You get this, especially during the springtime, you still get these colder air masses moving in from Canada. You get colder air, colder temperatures aloft above the ground over a more strongly heated surface, and that is going to result in convective instability, an unstable atmosphere. And April, by the way, is the main month for tornado season, as a strong polar front jet stream increases both directional and speed wind shear, and sharply contrasting air masses meet along potential cold fronts. So during the spring transition month of April across southeastern Virginia, you get, I look at the acronym SLIM, S-L-I-M. You look for shear, which you usually get a lot of shear. Directional wind shear is associated with changes in wind direction with height in the vertical above the ground. You also get speed shear, where there's major changes in the speed at different levels in the atmosphere. So, for example, at 5,000 feet above the ground, your wind speeds may be blowing, with a strong low-level jet stream, they may be blowing at 50 to 60 miles per hour. Down closer to the surface, they might be blowing, at a maybe 30 to 35 mile per hour rate. So you get this turning of the winds, a twisting of the wind motion. Sometimes you get this twisting of the updrafts, which causes severe thunderstorms. So I look at the acronym SLIM when I'm evaluating things. Shear, lift, Is there a lifting mechanism in place? Do we have the instability? That's the I. And the M is moisture. Is there moisture available? You look at these pictures, these two pictures I took during April in previous years. The picture on the left shows a layer of cirrocumulus clouds. Those almost like the speckly, they look like sheepskin. And then below that we have just regular cumulus clouds. The graphic on the right just shows sky. This was just taken recently, actually, this April, showing just a scattering of cumulus clouds across the sky. Additionally, these are the type of clouds you'll see during the month of April. I've seen these as we transition to more cumuliform shapes. So going across the screen for the pictures from left to right, I'll start with the left picture. I have just regular cumulus clouds that I've seen in the month of April. The second image, also cumulus clouds. And the third image there, cloud photo, is alto cumulus clouds. So now we have a cumuliform cloud in the mid-levels of the atmosphere. And then the graphic on the right shows cirrocumulus clouds. Again, it looks like that woolly sheepskin. So April is a big month across southeastern Virginia. As we transition to a basic cumulus cloud, we get other cumuliform clouds at different levels in the atmosphere. Again, the alto cumulus and the cirrocumulus. The bottom line is that we are transitioning to cumuliform type clouds. We're seeing that more than the layered stratus clouds as vertical heat transport becomes the primary heat transfer mechanism. Now, the summer season, this is an interesting time to view the sky. It's predominantly dominated by cumuliform clouds, including alto cumulus, higher level cirrocumulus. We even get occasional fair weather cumulus, and I'll show you a picture of what those look like, where we have lower humidity days and more stable atmosphere with fair weather cumulus. You can see a wide variety of cumulus types on a specific summer day, ranging from cumulus, building the tower cumulus, and then going all the way to a full-fledged thunderstorm, cumulonimbus clouds. Again, during the summer, specifically on a daily basis, you may start off with more atmospheric stability in the early morning hours, where you see these dull gray stratus clouds. They're a little bit more layered. But then they quickly change into cumulus and towering cumulus on most days as surface heating takes place. So on the following slides, I'm going to break down the specific cloud types during the summer season and what they mean. Starting off in general, what's going on in the summer season? We get these convective currents which develop, which are prominent with vertical heat transport, which reestablishes the balance between the much heated ground, excessively heated ground, and the cooler upper atmosphere. There's a large temperature gradient in the vertical during the summer season. And so, because of this, we get these towering cumulus and these cumulonimbus clouds to form. Now, air mass thunderstorms are quite common in the summer season, as we typically see that moist and stable maritime tropical air mass in place, which tends to want to rise. It's definitely more positively buoyant than other air masses with these air parcels during the maximum heating time of each day. After sunset, what happens is the instability will wane as the main heat source, the sun, obviously sets at night. So you may have some thunderstorms into the early evening hours, but they usually will die out after sunset, because we lose that main heating source, the sun. Now, a progression of low stratus clouds in the morning, followed by towering cumulus in the late morning, early afternoon, building to cumulonimbus clouds by late afternoon is quite common with air mass thunderstorms in the summer. Look at a couple of these pictures I took. The graphic on the picture on the left shows a billowing, towering cumulus cloud rising to great vertical heights in the atmosphere. And then the graphic on the right, I actually got that on an early morning. This was around 7 a.m. The picture on the right there, that cloud picture was at 7 a.m. on a summer morning. And you can see an anvil shape to the top of that cloud structure. It's actually an anvil. Let me see if let me bring up my drawing tool so we can take a look here. Okay. So I want to point out this is the anvil shape right here. Okay. And generally, this thunderstorm was on the Virginia-North Carolina border. I looked at the radar to verify this that particular morning. The overall anvil shape generally indicates the direction it points is the upper level wind direction. So that's really good information to glean from this graphic. All right, so summer season clouds, as you can see, I'm showing just typical sky during the summer season. These are all my own cloud pictures I've taken over the years. You can get a wide variety of clouds, a wide variety at different levels of the atmosphere. This particular graphic here on the left shows altocumulus clouds. They're kind of the flattened cumulus type shape there. The graphic here, the picture here in the middle shows cirrocumulus clouds. You see how tiny each individual cloud element is with cirrocumulus clouds? These exist usually above 20,000 feet in the atmosphere. And then the wispy cirrus clouds, which cirrus clouds are pretty much a year-round cloud across Virginia and pretty much across mid-latitudes as well. All right, so the wide variety of clouds exist, and many of these cloud types are considered debris clouds associated with decaying thunderstorms during the summer. So when thunderstorms dissipate, they tend to leave some residual mid and upper level moisture. You'll see cirrus, which can be blow-offs off the top of thunderstorms. You can see the cirrocumulus. You might see some altocumulus remaining from a dissipating or decaying thunderstorm. So a lot of these clouds, they're not associated with mid-latitude cyclones during the summer season because the main storm track shifts to the north. They're more associated, the variety of cloud types you see in the summer are associated with decaying or dissipating thunderstorms. Additional summer season clouds, some more towering cumulus pictures. I even got another anvil. This was in the eastern portion of the sky last year in the summer. We have more vertical development of a cloud above. These look like they're two different types of clouds, by the way. You see there's one particular convective element here with towering cumulus. Then you have a secondary convective cell, which is more flattened at the top, more of an anvil shape. And then you have even a taller cloud cell behind this anvil-shaped cell. This image shows very tall vertical building cloud, typical of the summer season. I mean, look at this, just really interesting. Look at the convective towers here at the top of this third image. And then look how narrow this one is, but it definitely demonstrates great vertical motion in the atmosphere on this particular day. I think I took this one in Norfolk, Virginia. But in general, these are the common clouds you're going to see on a daily basis during the summer. They indicate unstable air mass when you see these. Usually they're precursors to afternoon thunderstorm development. So you see something like this during the summer, it's a good indicator that you may see some showers and thunderstorms, gusty winds and lightning a little bit later in the day. Now, there's a thunderstorm side to the cumulus clouds in the summer season, but there's also a fair weather cumulus cloud that we can see on some summer days. These clouds taken during the summer. Occasionally during the summer you get a weak cool front to blow through the area, which temporarily decreases the low level moisture. You get high pressure to build in from aloft, and what that does, that high pressure, the air sinks, and it tends to put a lid on vertical growth to these cumulus clouds. So fair weather cumulus clouds have a very flattened appearance. They lack vertical growth. And as the name implies, these clouds are associated with fair weather. So if you see a cumulus cloud like this, notice how flat this is, right? All of this whole cloud field has relatively flat cumulus clouds. That generally indicates a stable atmosphere and fair weather by just looking at this cloud. I see this on a particular day, I'm saying there's going to be no precipitation this day because we have sinking air motion in the atmosphere. Additionally, I like to talk about cirrus clouds. Now, cirrus clouds exist throughout the entire year. They mean different things based on the season, really. They, for example, in the winter, could indicate the approach of a storm system, a mid-latitude cyclone. During the summer season, cirrus clouds can be simply blow off from thunderstorm tops. In wintertime, cirrus typically indicate the jet stream position. And also, cirrus can indicate the outer fringes of an approaching tropical cyclone. So I got 4 pictures here showing cirrus clouds throughout the course of the year. By the way, cirrus clouds make really good very good clouds for nice sunsets and sunrises. In general, though, you'll see more of a wispy shape to these clouds. They exist high above the Earth's surface, above 20,000 feet. And they're made up entirely of ice crystals. This one here, really, they take on a variety of shapes. Very wispy, as I mentioned. This one here almost looks to me like an angel shape. These are just really beautiful I think this was at sunset. Yeah, this was at sunset. I took this picture at sunset. And then here it looks like an artist just did an airbrush on a blue background sky. I mean, it was really a very interesting cloud formation. But again, cirrus occur throughout the entire course of the year. It's important to pay attention to the sky, well, not only for cloud shapes, types, determining the type of weather that may come, but sometimes the best indicator of the weather is by just simply looking up at a clear blue sky. Now, in these 4 pictures I took, note the deep hue, that deep color hue of this blue sky, all these pictures. When I see a sky with this kind of deep blue hue, I'm thinking one thing. I'm thinking fair weather. We have high pressure moving in. We have strongly sinking air motion in the vertical in the atmosphere. Usually these are associated, when you get no clouds in the sky, all get this deep blue color. It's associated with continental polar air or even modified continental Arctic air masses. The air column is usually very dry. This can occur throughout the course of the entire year as Canadian high pressure influences the weather. It's most prone to occur during the cooler winter, fall, like late October, November, December, January, February, even into March. It usually occurs most frequently then, but it can occur actually during, like this last picture, for example. This is actually during July. This is in Norfolk, Virginia. Okay, but in general, look at this. I mean, look at how deeply blue the sky is. By the way, the left-hand picture here that I took is in April. The second picture here is a picture I took from February. The third picture here, this is the governor's palace up in Colonial Williamsburg. And notice how blue that sky is. This was in November. And then July, again, is on the right-hand side. So with high pressure and control, you get this kind of deeply blue sky. You're expecting there's going to be no precipitation. It's going to be nice weather. Usually associated with low humidity too, by the way. Additional sky features and forecasting implications. I like to pay attention. You may have noticed these when you look up at the sky, these condensation trails, abbreviated contrails for short. Now, these contrails exist as jet exhaust cools and condenses into a visible trail in the upper atmosphere. You've got these airline planes flying at about 30,000 feet, 35,000 feet above us, and the jet exhaust comes out the back end of these, and as the heated exhaust comes out, it eventually cools and condenses and forms these trails across the sky. Now, what is so important about observing these? Okay, I look for 2 things when I look at condensation trails. The first thing is, how long do these contrails last? Do they dissipate rather rapidly behind this plane, or do they linger? If they dissipate rapidly behind the plane, it generally indicates a very dry upper atmosphere. But if they last longer periods of time and they widen, that indicates a more moist upper atmosphere. Here's an example in this third picture. This shows you a contrail that's lasting longer, and notice the shape, how it's wider. This contrail is wider than, let's say, this one, or even this one in the second picture. And then on dry days, when the contrail dissipates rather rapidly, that indicates it's very dry in the upper levels of the atmosphere. You most likely are having fair weather in place, and you most likely won't see any rain. Look how fast this trail disappears behind this plane. See that blue sky there? This contrail doesn't last very long. But on another day, look at this. This is towards sunset, looking west. Look how this one's lasting longer. See how much longer it is in length compared to this one? And so the length of time, the duration that these contrails last is important in determining upper level moisture, as well as the upper level winds. So if you get one that widens out like this and is longer lasting, you can know which way the upper level winds are blowing, what direction they're blowing from by just looking at these contrails. And so it's really important to take a look at this. Is the upper atmosphere moistening up? Is it drying out? If it's dry, is it associated with a high pressure system building in to the mid-Atlantic from the Midwest? There's a lot you can glean from just looking up at the sky again and looking at these contrails. Another thing I want to mention is something known as a lunar or solar halo. Now this is really interesting phenomenon. This occurs when you get light from either the moon or the sun refracting, bending of light. Refraction is just simply a bending of light from the sun or moon off ice crystals. The type of clouds we associate with ice crystals are cirrus and cirrostratus. Okay, so halos normally are associated with light refracting off six-sided hexagonal ice crystals in cirrostratus clouds. The graphic, or the picture here on the left, is one I took of a lunar. This is a lunar halo, and the picture on the right here shows a solar halo. So nighttime and daytime. During the fall and winter season, a halo portends an approaching storm system with precipitation possible within 24 hours. So that's why these are so important to look for. And the old adage is halo around the sun or moon, rain or snow soon. Again, these are usually associated with the approach of a mid-latitude cyclone or storm system during the fall and winter. Now, during the summertime, if you see one of these halos around into the sun or the moon, it's usually not indicative of an approaching storm system. Kind of what I alluded to earlier, where I said the main storm track and the jet stream shifts further north in the summer season. So you may just have a layer of cirrostratus in the summer producing this refraction of light in general, but it doesn't portend any type of storm system. So really, these are very important to watch for in the fall and the winter season. Another special type of cloud that's really, really important is what's known as Mimitus Clouds. These generally form on the underside of thunderstorm clouds, these cumulonimbus. And whenever you see these, now these are two actual photos I took over southeastern Virginia. When you see these clouds, they are indicative of severe turbulence, first of all. So pilots usually avoid these things because they could really be a problem for planes. There's a lot of turbulent motion in the atmosphere whenever you see these. These form on the underside of tall cumulonimbus clouds. Whenever you see these, you should be thinking to yourself, there's a thunderstorm either occurring or it's going to be nearby to your location. Some of the strongest thunderstorms, to include these tornadic supercells, usually contain Mimitus clouds, and these are more frequent. These aren't as frequent in southeastern Virginia, I noticed. I've only seen maybe about 5 cases of this over the last 4 years. But these type of clouds are definitely more predominant out in the southern plains, where there's tornado chasing safaris. A lot of professional storm chasers go out there to try to get tornadoes. These are very common out in like Oklahoma, Kansas, northern Texas with severe thunderstorms. But generally these are Mimitus clouds. Mamma literally meaning pouch-like. And then this was one of the craziest storms I can remember across southeastern Virginia. This is a wall cloud. And A wall cloud is basically a lowering portion of a cumulonimbus, a thunderstorm cloud. It's associated with supercell thunderstorms, which is a special, more intense thunderstorm. It indicates extremely dangerous weather conditions. When you think you're seeing a spaceship coming into your city, I mean, the circular saucer shape appearance of this cloud, this actually occurred in southeastern Virginia. This day was crazy. It was the day before Mother's Day. So this was in early May. And tornado warnings started occurring. I remember this. And I was out and about, and I heard the tornado warning come over my cell phone, and I was like, I think I'm just going to head back home. And so I got this from my house, but look at this thing. This thing, actual funnel clouds did form this day. There were multiple tornado warnings in effect, and the funnel is typically going to come out of this wall cloud. And so whenever you see something like this is a very dangerous weather situation. You have to be able to react quickly to the tornado warnings, because a tornado funnel could drop down out of this lowering wall cloud at any time. And then lastly, I want to talk briefly about tropical system clouds. I've seen a couple of tropical systems. Even the fringes of tropical systems impact southeastern Virginia, the mid-Atlantic, over the past 4 to 5 years. In general, there's a lot of variety of cloud types when you have tropical systems. The sky is going to look quite chaotic, with clouds ranging from basically covering all levels, high cirrus all the way down to low cumulus. You'll see just about every cloud type with approaching tropical systems. The cloud motion, you'll notice, is rather quick, rather brisk around the circulation center. And tornado warnings can often occur in the northeastern quadrant of tropical cyclones on very short notice due to directional and speed shear over short distances. Here's just 3 examples of cloud types I took, the sky, pictures I took with approaching tropical cyclones. In this particular image, I have more of a layered stratocumulus stack of clouds. There may be some enhanced instability within this cloud shield. This particular middle photo shows cumulus clouds. Above that, you can't quite see it, but there are some mid-level altocumulus. These low cumulus clouds in the far right picture were moving rather briskly, very quickly, generally from northeast to southwest on this particular day, as a tropical cyclone circulation was off the outer banks. And so you can see some higher clouds here too as well, some cirrocumulus and then low-level cumulus. But these low cumulus are moving very quickly on this particular day. So you can get a wide variety of cloud types of tropical systems. When I see a wide variety of cloud types like this, and they seem to be moving rather quickly, the low clouds, that is an indicator to me that there's a tropical system off in the distance, not too far. All right, so to summarize today's training, I apologize. I've got allergies right now, so I'm just kind of drinking water as I go throughout this presentation, to kind of like moisten my throat up. But I get kind of the tickle occasionally in the throat. So apologies for any throat clearing throughout the presentation. I'll just keep drinking water to keep my vocal cords moist. But overall, knowing how to read the sky and identifying specific cloud types is going to make you a great weather forecaster, period. The sky shows a predictable sequence of clouds throughout the course of the year as various pressure systems move in and out of the area, and various atmospheric processes are in play. Observation is the key to becoming a really good, successful forecaster. Watching the sky on a continuous basis, watching how the sky changes throughout the course of the year. Now, this guide is focused on southeastern Virginia, but as I mentioned, these type of clouds can be applied to all other areas of the U.S. as well. For example, on a stable atmospheric day, I'm going to see layered clouds, stratus. On an unstable weather day, I'm going to see more puffy clouds, cumulus. And that doesn't matter if I'm in Oklahoma, if I'm in New England, if I'm in the northern plain states, in Minnesota, if I'm down in Texas, it all is going to be the same. Now, some of the local scale details in your particular area may vary, but the general principles, again, remain the same. You get strong vertical rising air motion, you're going to get more of the cumulus puffy clouds. If you get more broad scale horizontal lift over gradual slope, longer distances, you're going to get more of the layer-like stratus clouds. But I have an extreme passion for clouds in particular, and if you can really master the art of observing clouds, identifying them, knowing what they mean, I could go out the door any day just after watching clouds and the way the atmosphere works in my particular area. I can go out the door any morning and I can look at the sky and I can say, okay, today is most likely going to rain, or today it's probably not going to rain, it's going to be fair. Because the clouds tell us those things. They're indicators that show us what's happening in the atmosphere, the processes that are occurring, and you can become an expert forecaster. All these clouds I've taken over time. And by the way, these clouds are also available on the Spot on Weather Weebly website. So if you Google Spot on Weather Weebly, check out the Weather Photo Gallery tab. I have way more clouds than just this. I have a lot more available if you want to check it out. But in general, clouds take on a variety of shapes. They take on a variety of sizes. We have more favored clouds during certain times of the year. Transition seasonal skies occur as well, from winter's dull gray stratus to summer's puffy cumulus. There's a lot of interesting things we can glean from just learning to identify and paying attention to our surroundings and the sky above us. So hopefully you've enjoyed this session, this training session on right here, forecasting using clouds. My name again is meteorologist Matthew Euler. I hope you've enjoyed this video. I will be moving into how the weather works training series. I'll be moving to part 3 soon, so stay tuned for that on the Spot on Weather YouTube channel. Looking at focusing in on some of the jet stream motion, focus on jet streams in general in the next training series. All right, thank you so much for watching. Thank you so much for subscribing to our channel. Take care, and God bless each of you. Take care, everybody.